labeled for us. I know we know our degrees in radians. It's those coordinates that are the newer information. So right here at 0 or 360, what's the coordinate location there? 1, 0. Okay. And at 90 degrees, what's our location? 0, 1. And at pi? Good. And at 270? 0, -1. Good. Okay. For 30 degrees, what is our coordinate for 30 degrees? Right. Square root of 3 over 2 and a half. Okay. And any of them that are 30 degrees away from the x-axis have that same set of coordinates, right? So 150 degrees would also be square root of 3 over 2 and 1/2. But in that quadrant, we know that the x value is negative. Okay? And 210 also would be square root of 3 over 2 and 1/2. But in this quadrant, we know right, x and y are negative. And then in this quadrant, we would have square root of 3 over 2 and 1/2. But we know that the y is negative. Good. Okay, what's our coordinate point for pi fourths? Right. Square root of 2 over 2 for both, right? Okay, and then all of our multiples of 45 are going to be the same thing, right? But in quadrant 2, we know x is negative. In quadrant 3, we know they're both negative. And in quadrant 4, we know that y is negative, right? Okay, and then what is our coordinate for 60 degrees or pi thirds? Very good. And it'll be the same for all the others, just keeping in mind, what we know to be true in each quadrant. So here my x is negative. Here they're both going to be negative. And here our y value is negative. Good. Okay. So on our unit circle, because we were plotting both the sine and cosine on our points, the unit circle, which is what goes in this blank, is both of those things graphed together. So this is a graph of our sine and our cosine that have been graphed together. Okay, and just like in any function, you plug some value in for x, you get out some value for y, right? You have some input, some output. Well, your input here, so that you know what your output value is you're looking at these things that are inside of our unit circle, right? Like our degrees and radians. Those are the input. Because I'll say, for what value of maybe pi fourths is the coordinate point, right? So your input is your degrees or radians. And then your output are these things out here, right? Your trig ratios. And specifically the ones on the unit circle that we have here are sine and cosine, right? So we know that this is what it looks like when we have them together, when we've got cosine and sine together. Now we're going to look at graphing the sine and cosine graphs separately. Okay, so they give us a chart to fill in. First, they say that we are graphing cosine. Well, remember, out of our coordinate point, cosine is the x value, right? Okay, so I'm looking at these values right here anytime they ask for something for this table. Okay, so they said when x is 0, or when my input is 0, remember my input is my degrees in radians. So when your degree or radian is 0, what did you get for cosine? 1. All right, so that's what goes here in the table. Okay, when my radian is pi halves, what did I get for cosine? 0. And when we had pi, what did we get? -1. And at 3 pi halves? 0. And at 2 pi, we would be back to 1, right? Okay. So just to make the graph a little bigger, I'm going to say that these are going up in increments of a half over here on the y-axis. Okay, so we are going to go and plot these points. So it says first we have a point when x is 0 and y is 1. So I go left or right, none, up 1. So I'd have a point right here. Okay? Then it says to go to pi halves and plot a point at a y value of 0. So I'm going to have one here. Okay, and then at pi, my y value is -1. So I'd be down here. And then at 3 pi halves, we've got a value of 0. And then at 2 pi, a value of 1. Okay. So as we know, there are a lot of things that fall in between those, right? We have 30 degrees, 60 degrees, and 3 pi fourths, right? A lot of things fall in between there. They're just giving you a few anchor points. Now, if you were to go graph all of the points that fall in between here, you would have more data, right? But these are the anchor points. This is what's going to give me a good idea of what my graph looks like. And just like whenever you graph the parent function y equals x squared and it has this curve to it, right? Oops, curve that looks like this instead of the absolute value function that's straight lines. If I were to plot all the points in between, I would see that this has a little bit more of a curve than just straight rigid lines in between it. So when I connect these points, it's going to look something like this. All right. Okay. Now I want you to do the exact same thing, but fill in the table and graph for sine. So that's what they said this one is for. So you tell me what those values are for sine, and then sketch a picture on the graph.
Is the first number is 0, and then under pi is 0, 2 pi is 0, is that correct?
Say that again.
I don't know.
Let me see what you're talking about.
I'm trying to see if I think I remember some of it from last year at school in Horace. Is that wrong?
Yeah, so at pi halves, I just look up here.
Yeah.
The y value is 1.
So then this is
Okay. Yep. All you have to do is look on here.
How are we getting y?
The same way we did on the cosine. No, in the coordinate point.
So the first one would be 0, the second one, -1. 1, 0. But you just like do a curve, yeah, no. Where it's only when these, one of these is not the same. Basically here it's asking so and the other one is asking for what's in the y coordinates. That's it.
Okay. So remember, guys, in all these coordinate points that are on the unit circle, that the x value is cosine, the y value is sine. So now I'm only looking at these values, right? Okay, so when I am at 0 radians, what is the y value there? 0. So sine is 0 because the y value is 0. Okay, at pi halves, what is sine? 1. At pi, and 3 pi halves, and at 2 pi, back to 0. All right, so whenever I graph these, I now have a point at 0, 0, at pi halves 1, at pi 0, at 3 pi halves negative 1, and at 2 pi 0. So if I go and connect these points, again, it's going to have more of a curve to it. So it's going to look something like this. Okay. So now that I have a sketch of these two functions, they ask us a few questions here at the bottom. It says that we need to go in and state the domain, range, zeros, or roots, and talk about what the transformation would look like between these two. Okay, so we're supposed to do this for each function. So let's start with cosine, the one that we graphed first. All right, cosine, the domain of this picture. Well, based on just the points we plotted, it appears to go from where to where? 0 to 2 pi, right? So I started over here at 0 on the x-axis. I went all the way over here to 2 pi. But if I were to ask you to plot 3 pi or 4 pi, if I asked you where 4 pi was on the unit circle, where would you tell me? The same thing, right? 2 pi. I would go from here to here. That's 2 pi. So 4 pi would just be one more time around, right? So the points just repeat themselves over and over and over. So if I were to continue this graph, keep going all the way out here to 4 pi, it's just going to have the same look to it over and over again, right? It's just going to keep going up and down and up and down, right? Same points over and over and over again. So, based on what we can see, yes, it would appear that it goes from 0 to 2 pi. But with our knowledge of the unit circle, we know that this is actually continuous. And can I also go in the negative direction on my unit circle?
Yes.
So I could go the other direction as well. So my domain actually goes from negative infinity to positive infinity, or all real numbers, however you choose to write that. So either write it like this, or all real numbers, whatever you prefer. Okay, what about for sine? What would its domain be? Same thing, right? We know the exact same stuff to be true as we continue around the unit circle. Okay, so also goes from negative infinity to positive infinity, or all real numbers. Okay. Okay, now we're looking at the range. So the range of cosine. So range is my y values. That's my up and down. So what does that look like for cosine?
1 to negative.
Right,
Negative 1.
between negative 1 and 1. Right. Okay, so the lowest it goes is negative 1. The highest it goes is 1. So we could write that this way. Or you can write it with your brackets, right, instead. All right. What about for sine? Same thing. So negative 1 to 1. Again, I'm good with whatever you choose to write it as. Okay. Then the next question wants to know where the zeros are. So for cosine, where are my zeros or my roots? So for cosine, we've got one at pi over 2 and another one at 3 pi over 2. If you were writing those as coordinate points, that'd be pi halves 0 and 3 pi halves 0. Okay? What about for sine? Where are they for sine? At 0. Mm-hmm. So I've got one at 0, 0. I've got one at pi 0. And I've got one more at 2 pi 0. Okay, so it looks like they have a lot in common. This is the first question we had a different answer for them, right? So on number 6, it says, what would be the transformation that would make sine, the second one we graphed over here, look like cosine, the one we graphed first? So I'm not wanting to compress it because they both currently have the same height, right, or amplitude, right? I don't want to make it any shorter.
Add 1/2 pi to each.
Okay, so what would that do to the graph? How would I be moving it?
Shift over.
Shift over, right? Shifting left and right would move it to where we want it to be, right? Okay, if I were to simply take this point, pi halves, and move it to right here at 0, the whole graph would be in the exact same spot, right? I would just be taking that section and scooting it over. Or maybe I take this one and move this point over here to pi halves, right? So it just depends on which graph you're looking at. So our answer here is that we would just need to shift it left or right, depending on which one you're moving. And we said we were moving it either pi halves back to 0 or 0 to pi halves, so I would be moving left or right pi halves, right? Oops, pi halves. Okay? So the reason they ask us about transformations is because that's leading into what we're going to talk about tomorrow. So I know you guys have done a lot of transformations in the past where you shift left and right or up and down, or like Akshay was saying about vertical compression, right? You know what those things are. Tomorrow we're going to go and apply that to our sine and cosine graphs. But today we're just getting familiar with the graphs themselves.